Good evening, students. So this is my name is Dipanshu Agarwal, and this session is in the continuation with the last session that has been done yesterday, right? So in the yesterday's session, we had solved the questions till question number 10, right? So we'll be continuing from question number 11 onwards from the XAT 2022 question paper, right? Okay, here we go. All right. So question number 11 says that Shireen, there's a person, Shireen, uh, draws a circle in her courtyard. Then she measures these circle's circumference and its diameter, and her measuring tape and records as them as two integers. So circumference is also an integer and diameter is also an integer, right? Okay. Now we have not been given the value of pi, right? This is the ratio between a and b, where a is the circumference and b is the integer, right? A and sorry, a is the circumference and b is the diameter. Also, she finds that a and b are co-primes. Okay, that means their greatest common divisor, or we can say the HCF, highest common factor, is 1. Right. So what she records is that circumference, that is A, divided by B, is coming as 3.14161416. So we can write it as 3.1416 bar. Okay. Now, this question looks like of geometry, but it's actually of decimal to fraction conversion, or fraction to decimal conversion, right? Decimal to fraction conversion. So this question belongs to this category, right? We actually have to convert this to fraction, and you should not assume this decimal as 22 by 7, which is the approx value of pi. You should not assume this, right? Because it is not mentioned in the equation that we have to take the circumference upon diameter as pi, right? So this is 3.1416, and there's a bar on 1416. So the first thing that we need to do is we need to convert this 3.1416 into fractions, right? Hmm. Okay. So we have to convert 3.1416 to fractions. And how we can do that? I hope you know that if we want to convert 0.x bar, if we want to convert 0.x bar to fraction, so it comes as x by 9. Similarly, if we want to convert 0.xy, and there's a bar on x and y, so it comes as xy divided by 99, and so on. This is the standard conversion from decimal to fraction, right? So applying the same thing in this question, so we'll be getting, yeah. So we'll be getting. Can I write this 3.1416 as 3 plus 0.1416 bar, and it can be changed to 3 plus 1416 divided by 9999, right? So by the standard definition of fractions, we can convert it to 1416 divided by 9999, right? Now we have to solve for this, and we will get 9999 into 3 would be 29997. 29997 plus 1416 divided by 9999, right? If we solve this correctly, yeah. So we have to add 29997 with 1413. So this should be 31413 divided by 9999. Okay, right. But if we look at these numbers, so see, the circumference upon diameter is given as 31413 divided by 9999, right? So this can be the value of the circumference and this can be the value of the diameter. But one more thing that has been given is, I'm really suffering from cold, so excuse me for that. Okay, so A by B is given as 31413 divided by 9999, and A and B have to be co-prime as well. That means they should not have a common factor except one. Okay, so we need to reduce this ratio to minimum, and then we can say that that would be the answer, right? So 31413 divided by 9999. Let's try to cut both these by 3. So this should come as, the numerator should come as 10. This would be 10471 divided by 3333. Okay. Now, if you try to cut this further, I don't think this is possible because you can see this. I hope you know this. So 10471 divided by 3333. Now, the numerator and the denominator are actually co-prime to each other because there's no common factor in this. You can see. You can try with different prime numbers. You'll not get any factor from this. So the value of A can be this, the value of B can be this, right? And if the value of A and B are given like this, so we have to find the difference between these two, A minus B, right? So if you solve this, 10471 minus 3333, so it will come as 7183, which is the answer, right? So that was our 11th question. Students, I'm not able to see your comments in between the question, in between solution. So I'll get to you. I'll get back to your questions after each and every question, after each and every solution. Right now, Karamveer is saying, okay. Karamveer, I actually don't have this much information. I'm not the experienced person to comment on this, right? So you can call our counselors and you can call the numbers given on the website and the pages, various pages, and they may be able to guide you much better than what I can do. Okay. All right. Let's go to the next question. So next question would be question number 12. It says the Madura Fruits company is packing four types of fruits into boxes. Okay. There are 126 oranges, 162 apples, 198 guavas, and 306 pears. The fruits must be packed in such a way that a given box must have only one type of fruit and must contain the same number of fruits as any other unit, as any other box. Okay. So 126 oranges are there, 162 apples are there, 198 guavas are there, and 306 pears are there. Okay, this is O, not Q, not zero. Right. So just let me change it to O. Okay. So let us assume that each box each box contains n number of fruits. n number of fruits. Okay, so n number of fruits would be contained by each box, and these 126 oranges should be completely distributed in n numbers, right? If there's a if just a second, yeah. So if suppose the value of n is 2, okay, so 126 is completely divisible in the group of 2 to 2 2, right? Again, if the value of n comes out to be 3, okay, then 126 is completely divisible in the group of 3333, right? Because it's a divisible number. Okay, suppose the value of n comes out to be 4, then 126 cannot be purely divided, perfectly divided in the group of 4 4. Okay, so in any case, if we try to divide 126 into a group of 4 4 fruits, then we would be left with two fruits. Okay, and those two fruits can't be put in another box. Those two fruits can't be put in another box because uh, each box should contain same number of fruits, right? So if we get n number of fruits, n number of boxes, so all of them should contain each number of fruits, right? Okay, and the number of fruits in each box should be a factor of 126, 162, 198, and 306 as well, because 162 has to be divided completely in the pairs of n fruits. 198 should also be divided perfectly in the groups of n fruits. 306 should also be divided in the groups of n fruits, right? I hope you have understood this. Okay, so this n number should be a common factor. This n number should be a common factor of 126, 162, 198, and 306. All of them should be a multiple of n, whatever the value of n is, right? Also, we want minimum number of boxes to be formed. If we want minimum number of boxes to be formed, then the number of fruits per box should be maximum. That's what we can say. The number of fruits per box should be maximum, right? So number of fruits per box, that means the value of n should be maximum as well, right? So what does that means? That means the value of n should be the highest common factor of 126, 162, 198, and 306. So it's not a very difficult question. It's very, very easy and solvable question. It's just that it has been asked in such a tough language that you are not able to determine, you are not able to catch that after all, it's just demanding the LCF or the HCF only, right? So we actually have to solve for the HCF of these four, right? And I hope you'll be able to calculate the HCF. The HCF of these four number would come as 44, right? Okay, let's move to the next chapter, next question. Okay, so next question says, question number 13. Students, there may be questions which are randomly put in the put in this sheet, but these were the questions in ZAT 2022 that has just been done 3 days ago, right? Not necessarily in the same order. If you have attempted the if you have written the ZAT, then you may have got this question at maybe number 26 or number 25 or number 12, maybe any number, right? So they were shuffled, right? But the questions were these only. Question number 13, it says, I have five 10 rupees note. So we have 5 into 10 rupee note. We have three 20 rupee note, 3 into 20 rupee note, and two 50 rupee note. So 2 into 50 rupee note. So these are the three types of notes that I have in my wallet, right? Yeah. So this is a question of probability. It says if three notes were taken out randomly and simultaneously, and what is the probability that at least 90 rupees are taken out? So we have to make money more than 90, right? 90 or 9 more than 90. At least 90 should be there. Okay. I can write here also. At least we should get the sum as 90. Okay. All right. So what are the various ways? Let's first pick the bigger nodes, right? And let's apply the cases in case in let's see what are the cases in which we can select the 50 rupees note. We can select the 50 rupee notes, right? So there are two notes of 50 rupees. So there's one situation in which we have both 50 rupees notes, both 50 rupee notes, and there's one situation in which we have one 50 rupee notes, one 50 rupee note. There cannot be any situation where we don't have any 50 rupee note, because if three notes have been taken out, so if we take the maximum number out of 10 and 20, then also three notes of 20 each will make only 60 rupees. So at least we should have one note of 50 rupees. That's the only way we will be able to uh, make the number greater than 90. Correct? Okay. Now, how to solve this? How to solve this question? So, first case is we have to take both 50 rupees notes, right? And we have to take one other note apart from these 50 rupees. So, that means in how many ways we can select these 250 rupee notes out of the two available 50 rupee notes? We can select, see, in the first case, we should have exactly 250 rupee notes and one other note, right? And in the second case, we should have one 50 rupee note and two other notes, right? So there are two cases. Now, first case is we have to select both 50 rupee notes. And in how many ways we can do that? 2C2. We can do that in 2C2 ways. Into, because we have to link this also in this case. I hope you know that between the cases we will use plus, but in between the parts of one case we'll use the multiplication. Okay. Now one other note I want to have from available 8 notes. We have 8 notes available. So 8C1 would be the selection of the other note. Plus, we have we have to select 150 rupee note out of these two available in the second case. So we should do 2C1 into, we have to select two other notes out of the available 8 notes, right? Not the leftover note of 50. We don't have to select the leftover note of 50 because that has been covered in the first case. Okay. So out of these 8 remaining notes, we have to select 2. Okay. So we have to solve this 2C2 into 8C1 plus 2C1 into 8C2 and divide it by total possible cases. Right. So let's solve this. So 2C2 would be 1, 8C1 would be 8, plus 2C1 would be 2, and 8C2 would be 8 by 2 into 7. I hope you know how to solve this, right? And should be divided with, this whole quantity should be divided with, how many notes are there? 5, 3, and 2, 10. All possible ways of selecting 3 notes out of the available 10 notes. Okay. So 10C3 should be in the denominator. Right. Now we should solve this. So this would be 8 plus 8 into 7 is 56. Right. 8 plus 8 into 7 is 56 divided by 10C3. So that would be 10 by 3 into 9 by 2 into 8 by 1. Okay. Right. So that would be 8 plus 56 would be 64 divided by uh, 64 into 6 would be there, and in the denominator it would be 720. Okay. So we have to solve this. Okay. We cut this by 8. So this would be 8 and this would be 90. And now we have to 8 into 6 is 48 divided by 90, which is not actually the correct answer. Okay, so I might have made some mistake somewhere. Let's check it again. Okay, so at least 90 plus money have to be formed. Okay. Oh, the simple mistake that we all did, that I did, was that these two other nodes have to be from this 20 only, right? Because these two other nodes, if they will not be from this 20, then we will not get 90, right? Suppose we have a node of 50. In the second case, we have a node of 50, and suppose we take 120 and 110, so we'll reach till 80 only. We'll reach till 80 only. So that means if we have picked 150 rupee note, so then we have to take the other two notes of 20 rupees, right? Yeah, so that's a little mistake that I did. So to correct this, I have to change this 8 to 3. So there should be 3C2. Okay. 3C2. Right. So I hope this is done. Now, yeah. So now I have to change this equation as well. The first one. So this will become 1 into 8 plus 2 into 3C2. 3C2 would be 3 only. 3C2 can be classified as 3C1, and that would be 3 only. And we have to divide it by 10 by 3 into 9 by 8 into 9 by 2 into 8 by 1. Okay. And now we have to solve this. So the numerator would be 8 plus 6, 14. Right? Into, we shall use this also in the numerator. So this would be 14 into 6 divided by 10 into 9 into 8. Right? Now, if we solve this correctly, then you will surely be getting the right answer, right? So this would be 3, this would be 4, this would be 3, and this would be 2, this would be 7. So 7 divided by 10 into 3 into 2, that is 60. So this is the correct answer. Right? I hope this is done. Let's move to the next one. Yeah. Okay. So the next question is Wilma Xavier Yaska and Zakir are four friends who have a passion about integers. Okay, just give me a second because I need to erase the initial questions so that you may be able to see the next questions. Right, just a second. Okay, so we have reached question number 14. It says W, X, Y, and Z. Let's not take the full name. W, X, Y, and Z have the passion for integers, right? So it is given that all of them will select an integer. Now, one day each of them selects one integer, it is also given, and writes it on a wall. The writing on the wall shows that Xavier and Zakir picked the positive integer. So we have to remember that Xavier and Zakir will be positive integer, right? Now Yaska picked a negative one. So that means Yaska has also picked an integer, but Yaska has picked a negative integer. Okay. Then Vilma's integer is either zero, either negative, zero, or positive. So that means W is also an integer, but it can be positive as well as negative. W is also an integer which can be zero, positive, or negative. Remember, zero is neither positive nor negative. Okay. Now let's take the first equation. So the first equation says W raised to the power 4, or let me write on this only. So the first equation says that W to the power 4, X to the power 2, 3, Y to the power 2, and Z should be less than equal to 4. Now there's a lot of hint that has been given in this equation, in this inequation. So W to the power 4 plus X cube plus Y square plus Z should be less than 4, right? It should be less than 4, less than equal to 4. So the maximum value of these four, the sum of these four can be 4. Okay. Now look at one of the option, one of the term X cube. So see, X is a positive integer, as we have just seen that X is a positive integer, right? So the minimum value of X would be 1, right? So the value of X can be 1, 2, 3, and so on, right? But as we can see that this can't be negative. W to the power 4 will always be positive, right? Y square will always be positive. Z cube, sorry, only Z. Z is a positive integer, so this will also be positive. And X cube, because X is a positive integer, so X cube will also be positive. So that means whatever, I just missed a trick, that W to the power 4 can be 0 or positive. I mean, this will not be a negative number. So that means, see, so that means that none of these terms, 1, 2, 3, and 4, none of these terms is actually negative, right? So that they can cancel out each other. Okay? There is no negative term among the first, second, third, or fourth term. Okay? So either they can be 0 or they can be positive. Okay. Now let's talk about x cube. If x cube is, if the value of x can be 1, 2, 3, and any of the given number, right? Any of the positive integer, right? So look closely. If we take the value of x as 2, so this will make 8. X cube will make 8, correct? And this would be much greater than 4, right? There's no other integer that can cancel or reduce this value, correct? Okay. So the value of x cannot be 2 or greater than 2. Okay. So we are left with only one value of x. So we are definitely sure that the value of x would be 1. Correct? I hope this is gettable. Now, if the value of x is 1, so put this into the second equation. So just put the value of x as 1 plus 1 cube will be 1 only. 1 plus z have to be greater than equal to 2. Correct? So from here, we'll get z as greater than equal to 1. Okay. So the value of z should be greater than equal to 1, which is actually given in the question, which is actually already given. Okay. Now let's look at another value. If this is 1, the value of this is 1, then let's try to calculate the value of let's try to guess the value of y. Okay. Now, okay, let's see from here the third equation. W to the power 4, W to the power 4 and y square. The sum of these two will be less than equal to 2. Will be less than equal to 2. And both of them will give non-negative values. Both of them will give non-negative values, right? Okay. So, can the value of y be equal to 2? Can the value of y be equal to 2? No. Because if we just write the y square here, so it would be 4. And if and w can't be negative, w to the power 4 can't be negatives, right? So from the third equation, the value of y cannot be greater than 1. Okay, greater than 1. But y is a negative integer, right? Y is a negative integer, so that means, just a second, yeah. So y is a negative integer. So let's see for the negative integer as well. Negative integer means y can be -1, -2, -3, and so on. But y square would be positive, obviously, because the square of the negative number is also positive, right? So still it can't have the value -2 and any of the greater negative value, any of the next negative values, right? Because if suppose I put -2 square here, then again it will be 4, which is not less than equal to 2, irrespective of the value of w. Okay. So this gives us a clue that the y can have only -1 value. Y can only have -1 value. Okay. All right. So we have finalized the value of y as -1. No, we have to write it somewhere else, y equal to -1, because this term would be 1. This term would be +1. Okay. All right. Now, z can be greater than 1. We know that the value of y is -1. We have finalized. Just put it in the fourth equation. So 1 plus z is greater than equal to 3. Okay. So from here, we'll get the value of z greater than equal to 2. Okay. Now, according to our fourth equation, we are getting the value of z greater than equal to 2. Okay. So the minimum value of z can be 2, right? And obviously 1 plus 1 plus 2 is equal to 4. So that means z cannot have the value of 3. If z will have the value 3, then it will go beyond 4. It will reach 5 at least. depends on the value of W4 as well. Correct? So from here, we get this that the value of Z would be 2 only. So we have finalized the value of Z as 2. Okay. So we can write here value of Z is equal to 2. And because this is 1, this term is also 1, and this term is 2, and the sum cannot be greater than 4. So therefore, the value of W should be 0. The value of W should be 0. So now we have all the values. Now we have to calculate the value of this expression W square, X square, Y square, Z square, right? So I hope you can do this. This would be 0, this would be 1, this would be 1, and this would be 4. So the possible value is 6. Okay. You'll see the answer in the options when I just drag this down. Okay, so I hope this is done. Okay, let me go to the next question. To go to the next question, let me erase this so that we have enough space to solve the next question as well. Okay, so the question number 5 says a tall tower has its base at point K. Okay, so there's a tall tower. This is a question of heights and distance. This tall tower has a base at point K. Okay. Now, 3 points ABC are located on 4 meters, 8 meters, and 16 meters, respectively, from K. So, let's draw a line. Let's draw a line parallel to the ground. So, the first point is located at 4 meter, right? The second point is located at 8 meter, which is B. The second point is located as at 8 meter, which is B. And the third point is C, which is located at 16 meter. Right? Remember, this complete distance is 16. Okay. Now, it is also given that the angle of elevation from the top of the tower to A and C, from the top of the tower, sorry, of the top of the tower from A and C are complementary. So if this is suppose theta, so this is 90 minus theta. This if this is theta, then this is 90 minus theta. Or let's take this as theta and this as 90 minus theta. Okay. Now let's take the height of the pillar or the tower BH, right, and apply the trigonometric formula in the first triangle. Let's take this point as D. So let's apply the trigonometric formula of 10, that is perpendicular upon base, in the first triangle. Okay. So that gives us the value of 10 theta is equal to h, the height of the tower, divided by 4. Right. This is our first equation. Now apply the same formula in this triangle, 90 minus theta and 16. So we will get from here that 10 90 minus theta will be equal to h by 16. Okay. And as you should all know that 10 90 minus theta is actually equal to cot theta, which is h by 16. Right. And also we can say that cot theta is, you should all know that the cot theta is 1 upon 10 theta. Okay. And this is given as h by 16. Okay. So what we have learned from here is 10 theta is h by 4 and 1 upon 10 theta is h by 16. Correct? Just multiply both these equations, this one and this one. So 10 theta and 10 theta would be cancelled. You'll get 10 theta into 1 upon 10 theta is equal to h by 4 into h by 16. Okay, right. So if you solve this correctly, you'll get h square is equal to 64 and the value of h would be 8. So you got the height of this star, h is 8. Now we have to calculate the angle of elevation from B. So that means we have to calculate this angle, right? So let's name this angle as uh, x. Okay, let's name this angle as x. Now applying 10 rule in this triangle BDK, right? The same rule we apply in this. So 10 of x will be equal to height is h and base is also h. So 8 divided by 8. Height is 8, base is also 8 in triangle DBK. So 10x equal to 1, and we should all know that if 10x equal to 1, then what is the value of x? 10 inverse 1 is 45 degree. I hope this is clear. Okay, let's move ahead to the next question, question number 16. For that, I have to erase the question number 15. Question number 15 is done. Let's move to question number 16. Question number 16 is also a relatively easier one, not a very tough one. Okay. So fx is given as log 3x minus 7 divided by square root of this equation, right? We have to find the domain of this. Domain means what are the value of x that we can put in this so that this function is a real function, not an imaginary function, right? For this to ensure that this is a real function, you need to know two things. First of all, if there's a format of a by b, then b should not be equal to 0. B should not be equal to 0. Okay? For a function to be real. And the second thing is that if log of something is equal to, if the function is log of something, if the function is log of something, so for this to be a real valued function, for this to be a real function, the value of x should be greater than 0. Value of x should be greater than 0. Is this clear, students? Okay, so accordingly, we'll calculate. So first of all, factorize this expression. 2x square minus 7x plus 6. I hope you know the factorization rule. I'm not going into factorization very much, but you'll get the factorization of this as 2x, uh, 2x minus 3 and x minus 2. Right? If you solve this, you'll get the factorization as 2x minus 3. No. I think I've made some mistake over here. Let's factorize it. So this would be 6 into 2, 12. We can write it as 2x square minus 4x minus 3x plus 6. So 2x is common. This would be x minus 2. Minus 3 is common. This would be x minus 2. So this would be 2x minus 3 into x minus 2. Yeah, so I was right. Okay, so 2x minus 3 into x minus 2 is the value that we are getting in denominator, right? So for this function to be real valued, the denominator should not be equal to 0. This should not be equal to 0. So where can this function be equal to 0? Where can this function be equal to 0? This function can be 0 at x equal to 3 by 2. This function can be 0 at x equal to 3 by 2 and x equal to 2. there are two values at which the denominator can turn 0. Okay. Now these two cannot be the value of x. Apart from these values, you can put anything according to the denominator, right? Now let's look at the numerator. So numerator is log 3x minus 7. So this part should be greater than 0. For this to be a real valued function, 3x, yeah. So 3x minus 7 should be greater than 0. Okay. Now 3x minus 7, if it is greater than 0, so x should be greater than 7 by 3. 7 by 3. So that means x should be greater than uh, 2.33. Okay. Right. Now see, if we look this closely, so the numerator says that the the number x should be greater than 2.33. Okay. Now, where is 2.33 on number line? Suppose this is 0, this is 1, this is 2. So 2.33 would be somewhere around this. So one of the numerator says that only this domain will work. Only this region can be the domain of this function. Correct? And the denominator says that the value of x cannot be equal to 2 or 1.5. Okay. So this has already been covered in the x greater than 2.33 equation. This has already been covered because obviously not minus, the 1.5 and 2 will be on the left side of 2.33. So the domain, or we can say the value that we can put in this formula, in this function, should be x greater than 2.33. And where's this in the option? We can see at B. So the answer should be 7 by 3 to infinity. I hope this is done. Okay, let's move to the next one. Let's take the doubts as well. LOC can't be negative. What is LOC? Okay, log. I think you must be writing log. Okay, so this is solved already. Let's move to the next one. Okay, so I'm erasing question number 16, assuming that this is done. Now we are moving to the data interpretation. Okay, so the quant section, the questions of quant section are done. If you have missed the last live session, you can see the recording of that. So yesterday and today we have completed the quant session, and now we are moving to the data interpretation part, right? For data interpretation, I hope you have gone through this question that has come in XAT. Let me just uh, reduce the size so that the data and as well as the first question is clear. Okay. I hope you can see the screen clearly. Okay, let me increase the size. Okay. All right. We'll see the options later. Okay. First of all, we'll try to see the data only. Okay. So in the questions of data interpretation, you need to understand the data very well. Okay. So this data is about uh, the particular stock. This is about a particular stock over 10 consecutive days. Okay. And the candlestick, this is called candlestick. This one and this one and this one, this is called candlestick. So the candlestick comprises of a rectangular box pieced by a line. pieced by a line. Okay, it should be pierced, but uh, I think that there's some typing error in this. So this is pierced by a line. The top and bottom of the line represents the maximum and minimum prices of the stock on that day. That means on the day one, the maximum achieved price was this, right? And the minimum achieved price is this, right? Suppose on day 5, maximum is this is the maximum, and this is minimum. Okay, this is the data. While the horizontal edge of the rectangle corresponds to the stock's opening and closing prices. So this rectangle, the horizontal side of the rectangle, this one and this actually represents opening and closing prices. Opening and closing prices. Now it is also given that if the rectangle is white, then the opening price is lower than the closing price. So if suppose I talk about this rectangle, okay, so the lower quantity is opening price and the bigger quantity is the closing price. Okay, so this is the question. Hmm. And in case of the black rectangle, in case of the black rectangle, it is other way around. So that means in the black rectangle, the opening price would be this and the closing price would be this. So this also gives us a clue that all the black rectangles have actually degraded their value from opening to closing, while all having the white rectangle have actually increased their value in the complete day. Okay, so this has to be remembered. Okay, now keeping all this in mind, let's solve the question. Okay, so the question is, on which day is the ratio of the maximum price? Now see, in data interpretation you need to exactly understand each and every word. So the ratio of the maximum price to the opening price, we have to calculate that which is in which day it is highest. Okay, on which day it is highest. So maximum upon opening means the ratio should be highest. So maximum is this. Okay, opening price is this in the first one. Maximum is this, opening is this. Maximum is this, opening is this. Maximum is this, opening is this. Because in the black rectangles, it is other way around. Correct? Maximum is this, opening is this, and so on. Right? So we have to calculate which ratio is highest. Okay? So see, to calculate that which ratio is highest, we don't need to actually calculate the all ratios. We have to first look at the options and try to calculate the answers according to option. So in the option, just a second. Yeah. In the option, which days we have to calculate? We have to calculate for day 3, we have to calculate for day 4, for day 9, just take this, right? Day 10 and day 1. So only 5 days, for only 5 days we have to calculate. So now we have to take the maximum and minimum ratio, right? Okay. For day 1, the maximum and minimum ratio would be uh, this one. So this should be 2 4 1 5, something like this, 2415. Okay, divided by the opening price. The opening price is this, 2 3 6 5, we can say. So this is the approx value of the first maximum to opening price. Okay, now let's look at day 3. So day 3, the maximum is this one, 2440, and the minimum, sorry, the opening price is this one, 2420. Okay, now day 4. Day 4 would be around 2455 divided by this would be the opening price. So that would be, I think, 2435. Okay. Now day 9 would be, yes. So day 9 maximum is around 2330. 2330. Students, this data we have to accumulate very carefully, right? We can take the plus minus 5 data. That is not a very good, very important issue, but we should try to take the exact data, right? Now this I can say as 2295. So this would be 2330 divided by 2295. Now we move to the next one. Next one should be 2330 divide by the opening price would be something here. So that would be 2275. Okay. Now we have to compare all these datas, and I have to check whether they are which is the highest among these, right? So we can actually neglect or discard some of the data without even going inside it, right? For example, see, if we look at these two values, so these are very close values, 2455 and 2435, just as a difference of 20, right? And uh, this compared to the day 10 data, which has a difference of around uh, this has a difference of around 55. Okay. So with a smaller denominator and a very high numerator comparatively, we can say na, that this cannot be the highest. This ratio cannot be the highest, right? Similarly, this also has a difference of only 20, and the denominator is much larger than this, right? Denominator is much larger than this, and the numerator is not so much larger. The numerator is not so much larger than the numerator. So we can say that this will also not be the answer, right? Now compare the data from here. So the numerator is almost same. If we have recorded it correctly, let's erase this. And if we compare between day 9 and day 10, so numerator is same almost, but the denominator is is less than is less in this case. The denominator is less in this case. So the fraction having the lesser denominator will always be higher than the fraction having a larger denominator. Okay. So this can't be the answer. So we just have to compare the rest two. Okay. Okay. So in the day one also, we see that there's a difference of 50 between numerator and denominator. And the denominator is much higher than the denominator of day 10. Okay. So the denominator is higher and numerator is not that much higher. Okay. As this one. So I think you should all know how to compare these type of ratios. That is a completely different domain. Okay, I'm expecting that you all know these type of tricks, how to take the difference of the how to compare the ratios and the fractions, right? So from my point of view, we'll get the answer as day 10, because the difference is less and the numerator is higher. in the case of day 1 also. So that's how we compare a fraction. So day 10 should be the right answer for the question number this 16. Okay, let's move to the next one. Okay, to move to the next one, I have to erase all the things that we have done in this one. Right, just give me a second. Yeah, and now we should erase question number 17 as well, so that the next question is visible. Okay, so I'm placing the chart in such a way that question number 18 is also visible and this chart is also visible. We reduce its size. Okay. All right. So question number 18 is asking us that what is the highest magnitude of change. We are not being asked the percentage change or the relative change. We have been asked the magnitude of the change. That is the absolute change. Okay. Over the two consecutive days. For example, if day 1 is considered, then day 3 would be the next data that we have to take. So day 1 to day 3 or day 5 to day 7, we have to calculate, right? So we have to find the maximum price touched by the stock during the 10 day period. Okay. So we have to arrange, we have to see from the options that for which of the option we have to calculate the prices. Okay, so the magnitude is given in the option, so we don't have a clue from the options as well. So we have to solve it without looking at the options. Correct. So we have to find the highest magnitude change in the maximum price touched by the stock in a day. Okay. So let's start with the first one. And we have to measure only the change, not the increment or the decrement, right? So let's compare the first one and the third one. So it is a change of, let's take it in the form of bars only. So this is the change of, right? I'll take this much distance as 1 bar. Okay, you don't need to go in very much into the data. You can just see it by calculating it in the terms of bars. Okay, so if we see correctly, so this difference, this and this, is something like 1.2 times the bar. Okay, and obviously you can see that this and this is less than our initial one, the first one. Okay, let me write it clearly. Let me write it in the denominator, in the yeah. So if we compare this one and this one, the maximum quantity of this day 1 and day 3, so there's a increment of 1.2 times the bar, that is 20, right? This value is 20, but we don't have to actually calculate it. Now, if we take the change from second to third day, sorry, second to fourth day, so obviously you can see that this difference is less than 1 bar. Okay, so obviously this is greater. So we can ignore from second to third, sorry, second to fourth. Now take the change from third to fifth. Okay, so third to fifth is a difference of 1.2 bar. Okay, so this also have to be taken into the consideration. So these two have a change of 1.2 bar. Now let's take this, let's compare this one and this one. So there's a difference of, as you can see, around 2.6 or 2.8 times the bar. There's a difference of 2.6 times of the bar. Okay, so now we can cancel this because we have got a higher value, much higher value. Okay, so we can erase the rest of the things and we can now see whether any other day has a difference of greater than 2.6 or not. Okay, right. Now let's see the next two. So how much this distance is according to you? I think this is less than 2.6, right? So we don't have to consider this. Okay. This is all pictorial, right? You don't actually have to go into the data to solve this question, right? Okay, next two. So this one and this one. What is the difference? Yes, this is beyond 3. Okay. So if this is beyond 3, so that means we have got a new value, right? So we should write these two. Okay. So this should be around the difference between this maximum and this maximum should be around 1, 2, 3, and 3.6, something around 3.6 bar or 3.5 bar. Okay. Now let's check the next one. So this is here and this is here. Obviously, this is not greater than 3.6. And this are almost equal. Okay. So we have got our maximum value 3.6 times the bar. And what is the value of 1 bar? 20. So this answer should be somewhere around 70. Yeah, this should be around 70 or 72. Right? This answer should be somewhere around 70 or 72. Okay. So let's see the answer. Answer is 70. Okay. That's how we solve this question. Question number 18. I hope this is very much clear to all of you. Moving to the next question. I'm erasing question number 18. Okay. Okay. So we have to find that on which day is the ratio between maximum to opening price is the highest across the 10 days. I think we have just done this question. I think we have missed some question because this question has already been done. Okay. Just give me a second. Let me check whether whether I have copied the question correct or not. Because question number 19 type of question we have just done. Just give me a second. Yeah, right. This we have done, but we have to. Sorry. There was another question. I have mistakenly copied the same question. Okay. Just a second. Okay. This should have been the question. Question number 19 should be this. Which day saw the maximum percentage increase in the stock price? Which day saw the maximum percentage increase in the stock price at closing from opening, right? And what we have to check for? We have to check for day 1, day 7, day 10, day 6, and day 2. There are these are the 5 options in which we should check. Right. So it says the maximum percentage increase in stock price at closing from opening. Right. So closing, sorry, opening, closing. Right. This is opening, this is closing. So we have to find the percentage increase, right? Now it is a very it is a very good hint in this, that if they are asking the percentage increase at closing from opening, so obviously closing should be greater than opening. Closing should be greater than opening, right? Otherwise it would be a decrease. Okay, so if closing is greater than opening, so that can only be possible in the white rectangle, right? Because in the black rectangle, the closing is less than the opening price, right? So we have discarded, we can straightforwardly discard some of the options, like day 6 discarded, day 7 discarded. So we have to just check for day 1, day 2, and day 10, right? Okay, so let's check this. So in the first one, we have a difference of 2360, and this is 2 this would be 2415, 2415. Okay, and divided by 2360. Sorry, 2415 minus 2360, divided by 2360. Right. So the numerator of this would be 55. So 55 divided by 2360 is the data for the first day. Right. So 55 divided by 2360. Right. Let's see the next day. So this is 2 4 sorry 2 2 2 4 3 5. This is 2435, and this is 2385, right? What is the difference between 2435 and 2385? 50. The difference is 50. Okay, right. So this would be 50 upon 2385. 50 upon 2385. Let's check for the option number 10 as well. So 10 would be, uh, yeah, so this should be taken as 2330. Yeah, 2330. And this should be taken as 2255. 2255. Correct? So what is the difference? But this would be 45 plus 30, 75. So this would be a difference of 75 out of what? 75 is the difference out of 2225. 2225. 2255. Right. Now we have to find which one is maximum. We have seen that the maximum percentage increase from closing to opening time are this, and this. So as you can see from here, that just a second. Maximum percentage increase. I think the answer for this should be 10, day 10. The maximum percentage increase, or oh, we have actually solved it wrong. We have taken the maximum and minimum of this. We need to take the opening and closing price, right? No one actually reminded me. We have to take this one and this one, right? So that's what we have done here wrong. Okay, let's quickly try to calculate. So this would be 2 395, and this would be 2365. So this would be of 30 divided by 2365. Okay, right. The next one would be 2425, and this would be 2395, right? So this would be a difference of 30 divided by 2395, right? 30 divided by 2395. And we see here, so here it is 2290. We can take it as 2290, and this we can take it as 2275. Okay, so what is the difference? 15 divided by 2275. Okay, now we have to compare all this. See, we have to calculate the maximum out of this, right? So can I change it to uh, 30 divided by 4550? I have multiplied the numerator and denominator by 2. Okay. Now this is all clear. We have to compare this, and this. So the least denominator, because all the numerator are same. So the least denominator will have the largest value, right? So that's why the answer is day one, right? Okay. All right, students. So I think this is done. Shouldn't we take the opening and closing prices? Yeah, right. I actually missed that. Sorry for that. Yeah. Okay. So, students, that's it from my side for today's session. It has already been more than 1 hour of live session. So, in the next session, tomorrow or maybe day after, we'll be solving the rest of the questions, right? So, we have this DI set remaining, which has 3 questions, this DI set, which has 3 questions, and this DI set, which has 3 questions again, right? So, we have 9 questions of data interpretation remaining, and we will continue to all these we will end this data interpretation tomorrow or in the next session, whenever it will be. Okay, so for today's session, that will be all from my side. I hope you like this session. All right, so that's it. Okay, thank you. Bye bye. Good night.